Welcome to the Making of Me podcast, where we explore the experience and challenges that shape us into who we have become. Today we'll be speaking with Jessica Patel, back-end engineering leaders and testing specialists, helping team ship reliably software with confidence. It's really a pleasure to have you on the show, Jessica.
Thank you, Errol. Thank you.
Yeah, thank you so much. So, Jessica, what were some of the challenges or moments that actually shape you to who you have become today?
So, to begin with, I would say, you know, growing up in an environment where, first of all, women, are not too much into engineering and academics, I would say. So, getting past that stereotypical environment, right? And to set an aim in technology booming era, I would say, and having that vision that one day I would be an engineer, like coming here to the US was a dream, I would say, which I had never intended, and it just happened purely based on talent and hard work. And having this journey all the way here, was not easy. So it's like you face a lot of challenges in terms of fast growing technology, right? And the fact that you have to cope up with it and you constantly have to keep learning, um, and challenging yourself, that itself in it is a big, I would
Yeah,
say, thing. Yeah.
yeah,
And through this, I think these things just shape you in a way, you don't even realize, I feel. Yeah.
yeah, amazing, amazing. It must have been very, very difficult being that. I think learning is easier most times if you have people who has the same goals, who have the same aspiration. More like you actually get to do it at a team, not at a lone ranger. So how was it like for you being that in your environment there was not much persons driving towards engineering? What motivates you and how did you get started?
I would say that growing up, like it was purely the fascination of seeing a computer and
Mm,
seeing how you could create like those small programs. I remember we used to start by creating stars, and it used to be so fascinating back then when we were little. And my father used to kind of use this at his work. He was quite aspirational as well when it came to, me. He never looked at me as just a girl, right? And maybe he saw something in me, and then he got the computer at home, and I was like, and one day, like, somebody just asked me, what do you want to be? I guess one of my teachers in my middle school or something. And I was like, I want to become a computer engineer. And it just came out, I mean, no thought, it just came out. And I was like, okay, a lot of my other friends were like, oh, I want to become a dentist, I want to become doctor. And I was like, no, I think I'm pretty firm. I want to become a computer engineer back then. And it just, happened.
wow, wow. Okay, so more like, how did you actually overcome the difficulties when it comes to, you know, I think before you actually get to become an engineer, there's a whole lot of demand. The thing that I think for me, I graduated as electrical electronic engineer, and I know that despite I make that particular wish when I was in secondary school that I want to be an electrical engineer. I went through a whole lot. I'm like, which at one point I almost gave up and actually were like leave it all out owing to the difficulties. So what kept you going during those period of
I think that constant urge, that curiosity, I would say, the curiosity to look beyond,
Hmm.
always, right? To see what's more, what's after this, and to believe in the fact that, if you want to shape yourself well, you have to go through the toughest temperatures. Like you have to curate
Hmm.
yourself and then, if you want to get into that shape. I think that's what kept me going, I would say, all these years. And even now, like, there has not been a single day in my career where I would say, you know what, I don't want to do this anymore. No, I don't think so. And I like that. I like that. I have the
Yeah.
excitement and I go to work, thinking that, yes, asking myself, like, what problem am I going to solve today? Right? Okay,
Hmm.
let's go and see. Let's see how we
Wow.
can change things, shape things, better, right? Yeah.
Yeah, that's really amazing. I think it's the fact that I think engineering now, there's a whole lot of challenges to actually come by, and just having that mindset. Yeah, what problem did I have today? Which one should I solve? What is going to be the unknown that is going to be known today? I think that perspective is really lovely, and the more you get to kind of do a whole lot of them, the more energized you are towards looking forward to bigger more. And yeah, it's really amazing. Yeah. Yeah. So why is it testing first mindset so important in modern software development?
I feel, today we are moving so fast in technology, right? We really need to kind of strike a very good balance between the speed at which we are moving and the reliability of the systems. Like, you need to still build reliable systems while you are racing towards delivering things, right? Because everybody, it's like it's such a competitive environment, especially in technology, that, if you snooze, you lose. It's like that. It's
Yeah.
like that, right? So you constantly have to, deliver things to your customers. And coming from a company which is like providing, like, we provide solutions to affordable, I would say, affordable and sustainable rental housing and home ownership to millions of people in the United States, right? So it becomes really important that when you build reliable systems, it's not that reliability in general, I would say, is not just a technical goal, it's a responsibility, right? And in this kind of environment, the key is that the only way, I would say, you can achieve this reliability in the process early is through good test coverage. Of course, there are other like engineering patterns and design best practices also that we should look at in a way. For example, you have circuit breakers and stuff that you can put. You need to have solid observability, but of course, testing is something which is very key and important for you, to kind of help you move faster and build reliable systems.
Yeah, amazing, amazing. So how is AI changing back end engineering workflow today?
Oh, yeah, everything is AI now, right?
Yeah.
I would say that it's shifting, I would say, a lot of like boilerplate burden, like the scaffolding code, that writing initial tests, generating documentations. A lot of these places is where AI is now helping engineers. So taking away some of that responsibility from coding and that initial boilerplate and stuff like that, right? And giving people time to think deeper into building like good designs, right? Like myself at this moment, like, I now can take a step back and put more thought towards building these good systems and reliable systems, designing them and architecting them, right? Focusing more on my business requirements, working with them more closely to understand what are their challenges. Because I know with AI, coding is not going to be a problem, right? Telling what to code or understanding the ecosystem is very important
Yeah.
now. And that's where I think we can shift our focus more, right? So I wouldn't say that, I know a lot of people think that AI probably is kind of taking away their jobs, but I wouldn't think of it that way, right? I would say while AI is your pair programmer, I would, right? Think of it as can't easily replicate your domain knowledge, right?
Yeah,
It
so
cannot,
true.
yeah, the intuition of the system design, knowing why a business works in a certain way, those things AI cannot kind of take away from you, right? And in this day and age, I feel the only engineers that will thrive are the ones that will kind of leverage AI as their
Yeah.
productivity multiplier, right? While they own the architectural decisions
Yeah.
themselves,
Yeah, so true.
right? Yeah. So
Yeah, yeah, I think it's really lovely being that adopting AI, getting to know a whole lot about it so that you can actually get to kind of, yeah, make your work faster, being that, yeah, time has changed and what worked yesterday might not work today. So I think
yeah,
working with it rightly so that it can actually enhance your productivities and also being able to kind of bring your idea very fast to fruition before the actual product. I think it's, yeah, it's really key being that AI actually more like help, being that you already have the design principle and how architecture actually get to work when it comes to the back end. So AI actually more like, yeah, sharpens your foresight on what to ask and how to create. Because even if AI can do it, your prompts and knowing what to ask is a whole lot, and you can only ask something you have seen before or something you have experienced.
exactly. I totally agree, right? If you don't know what to ask, AI is not going
Yeah,
to do that for you, right?
so true.
So it's important, and I always feel that it's going to always be like a good marrying between
Yeah,
AI and a human in the loop, right?
yeah,
It's
so
going to
true.
be very important to marry them together well. Yeah.
And it's really lovely. I think for those who already have the dominant skill, leveraging on AI is make it easier, being that they can do 10 times X, 10 times X of the work they do before in a shorter period of time without having to kind of being burn out compared to when they have to code every single line. Yeah, I think it's a very big leverage. But just that it's a demanding one, being that you just have to keep catching up with technology while you still have your dominate your knowledge. Like, yeah, amazing.
That's true. That's true.
Yeah, thank you. So, what are the common mistake team make when adopting new technology too quickly?
I think the most common mistake that they do is, whenever like, and I've seen this personally, like, working for last 17 years,
Yeah.
is to jump to designing too quickly, right?
Mm,
I feel that in order for you to design a system, uh, you first need to understand the requirements properly. You need to make sure that you plan for failures. I think that's where most of the systems fail. They jump to designing quickly without asking that question to yourself that, hey, first, do I understand, what is the requirement? Two, always people need to ask, like, what happens when it fails before even we finish designing, right?
yeah.
And that's where I feel a lot of systems are failing at this point, not able to, adopt to certain resilient patterns, right? Be able to, and just designing is not the only thing in today's, day and age. How do you recover from an issue? You need to have those guardrails in place as well, right? A lot of these observability, run books, so many things you need to kind of think of, right? Because if something goes wrong, we need to be able to fix and react to it in more calm fashion and yet faster. So I think that's where I feel a lot of people or systems fail in a way.
Yeah.
They are not able to kind of think beyond the designing, because anytime you ask an engineer, oh, they are very excited to design things, but I'm like, you have to take a step back first and
Yeah.
understand the ecosystem and the boundaries as well.
Yeah, I think this is really lovely. Being that, thank God we are talking about it. Being that having AI as something that could actually generate a whole lot of persons are actually more like quick to jump into doing anything, and even when you get to the app store now, you're going to see thousands of apps that are not actually more like working, or they are not actually more like serving, or the customer does
Yeah.
not even think they need it. Mean that, yeah, the thought has not gone through. They just jump into AI, which I think we can create anything. By the end of the day,
Yeah.
does the customer want it? What how is it sustainable? Even if they want it, is it something they are willing to pay for now? And I think there's a whole lot of background thinking you have to kind of go into before you actually like come into a conclusion of, yeah, maybe this is viable or
That's
not.
where I feel, to your point, right? I don't think AI can give you all of that. It's you who have to think
Yeah, yeah,
about these things, right? And only experience can
Yeah,
teach you these things, I would say. Yeah, yeah.
yeah, yeah. Thank you. So, what role does cloud native architecture play in scaling products responsibly?
They play a huge role, right? Because I would say there was a time, and in my experience, right, I have seen applications which are in the on-prem architecture, right? In your on-prem data centers, where if I say, and there was a very weird incident where we were thinking about how can we do our performance tests a little earlier, right? Because it was like in a system where we will be coding and testing, locally teams will be testing, and then probably 1 month after the code is done is when we will say, hey, my performance testers, like, hey, come on, test my system. And that's when we will come to know that things are not, like, probably not ready yet, it is not able to take the volume and things like that. And at that time everything was on prem, right? And then we were thinking like, hey, how can we move some of these things left? But it would mean that you have to stand up new, servers, and it was a cost, it was
Yeah,
time consuming, right? With cloud, things have changed. Like, if you want an instance, I mean, the capabilities that cloud provides, right, of auto scaling based on either your CPU utilization or your memory, right? It's so easy now to provision infrastructure in cloud than it was before. And also, the type of services that it offers to teams is very vast. Before, even for small change, I literally either had to like deploy, reserve like a proper server, right? And I didn't have an option of saying, hey, give me a small versus a medium versus a large. There was no option like that before, right? But now, based on your needs, you can provision infrastructure, you can save cost, right? And you can scale based on your parameters, right? And that's the beauty of cloud native architecture, right?
yeah,
I know it comes with its own cons as well, but I feel the pros are more than the cons. And you can still tackle the cons if you build like a fail safe architecture, right? Where in cloud you have disaster recovery in your application built in, where you have your infrastructure set up in east 1, east 2 both, and in case of a disaster you fail over on the other side, so that way you have like very minimal downtime for your
yeah,
business. So you can still bake those in to kind of tackle with the cons that come with the cloud native architecture, right? And you can, but there are so many things that it offers, from cost optimization all the way to your scalability and reliability. That's very
yeah,
important. Yeah.
yeah. Amazing, amazing. Thank you so much, Jessica, for sharing. So, Jessica, before you go on, what advice will you give to engineers who want to move into technical leadership?
I would say, in order to be a good, I mean, a good technical leader is not just someone who would just, give a smart advice, but it's someone who makes the team smarter and the room smarter. A good technical leader is also someone who is not just like a good coder or somebody who's good at designing, but to be able to communicate that design in a way where your business can understand, your teams can understand, and can act on is also very important. Like, you might be the best coder, but if you are not able to resonate or translate that design thinking or to your teams, or channelize to your teams in a more understandable way, then it's a problem, right? So a good leader is someone who is able, should be good at communicating too, right? And
Yeah,
who is able to kind of influence the team in a better way, right? For example, just don't just say that, okay, if you are like an advocate, for example, I'll take test driven development as an example here. If you are an advocate of test driven development, don't just tell your team that, hey, TDD is good,
Yeah.
right? That makes that won't, or we have to write, or you should write tests first. That's not, you should lead with outcomes. And that's what a
Mhm.
good leadership is, that you have to lead with outcomes. You should say that, hey, you will have fewer late night incidents, or there'll be a faster onboarding for new engineers. We can go more confident when we are refactoring things. We'll be more confident when we are touching any code. Or in today's day and age, like cybersecurity and vulnerability is such a big thing now, right? So constantly we have to keep updating the libraries, right? So how do we do that with more confidence? These are the outcomes that you have to kind of be able to
Yeah.
explain to your developers and team, so they understand the importance of some of these best practices. That's a very important quality that a leader needs to have
Yeah.
in the project.
Amazing.
Yeah.
Amazing. Leading with outcome. I think this is really lovely being that engineering is not a field where you just need to speak grammar. You need to know what you're saying beyond words.
You need
Yeah. Not just words alone. Yeah, beyond words and even beyond actions. You should be able to explain it in terms of words, and also you should be able to demonstrate it or how the outcome is going to be like. I think that is the only way you are going to value and everything. Because if it is only in knowledge, ChatGPT can give you knowledge. Well, irrespective of the experience and what the outcome is going to look like, you have to tell it to be, yes, with conviction that this and this, the certainty behind it. Amazing. Also, Jessica, for young girls who are out there looking forward to men dominated field, what would be your final words to them?
I would just say for the young engineers, right? Don't worry about, I would say, coding. AI can help you with that. But worry about understanding the strengths of the language that you kind of learn, right? So, what are the strengths of the languages? How the internals work is still important to understand. While you think that, hey, don't just say that, okay, why should I do this because AI is there? What help? Why do I need to spend my time here? But it's still important, you know, to know the basics and always focus on, I would say, to communicate your technical decisions in a better way, right? So the engineers who advance the fastest are not just the best coders. They
Yeah,
are the ones who can explain the code, the trade offs to a non technical stakeholder, and
yeah,
are able to write or document, them in a good way such that you can are able to explain it. And that's where I feel, um, you know, uh, when you write yourself, your thoughts is when you understand it much better, right? So try to kind of, write more about your thoughts, whatever you're learning, just try to write and see if you're able to explain it well to someone, because that cyclic
yeah,
feedback loop is going to help you learn better, right?
yeah, so true.
Yeah, and don't be afraid of, not knowing things. In fact, it's a good thing that if somebody asks you about something and you don't know, I think that gives you another motivation, right? And another way of, okay, maybe I didn't know this. Let's go. Let's be curious. Let's learn about it, right? So
Yeah.
always be curious and keep asking for more questions, right? And more feedback. Yeah.
Yeah, this is really amazing, especially when you make reference of the fact that, yeah, beyond just doing the technical parts, know how to communicate. Because at the end of the day, it seems those who are highly paid, those who are highly remembered, are those who could actually more like, yes, convince of what the product can do. Yeah, beyond the
Yeah.
technical aspects in terms of wording and everything. And they are the one who gets the bigger projects, the bigger money, the bigger, yeah, things to actually execute that project compared to the doers. Because yeah, the talker actually win the day more compared to the doer. So beyond just doing, learn how to talk, learn how to communicate, and learn how to kind of
Important.
put out your trust. Because
Yeah, it's very
lately,
important that you're able to share what you have done, share your learnings with everyone, right? And that helps you learn as well. Because
yeah,
when
I
you
think
share,
yeah,
you get more questions and you
yeah,
get, you learn from
Yeah.
it, right?
So true.
Yeah.
So true. Because sometimes I don't even think we know what we think until we pen it down, until we communicate it, or until we actually get to write it. It's when you write it, you're like, did I say that? Did I really mean it?
Yeah.
And I think it's really lovely, more like sharing most times, and it strengthens your conviction about a particular project and you being able to kind of do it differently. Yeah, it's amazing. Yeah, thank you so much, Jessica. So, Jessica, from our audience who want to learn more from you, or who want to reach out to you, and those who actually want to do business with you too, how can they reach out to you, and where is the best platform?
So I'm available on LinkedIn, of course, and I also do blogs in Dev2, Hackanoon, Free Code Camp. That's those medium where I try to kind of share some of my learnings,
Yeah,
my thought process, some of the topics that I'm exploring. I see if I'm able to share and communicate it with the broader audience, my thoughts and my ideas. Yeah, so they can reach out to me there too.
yeah. Thank you so much, Jessica. Thank you for sharing your insight
Thank
on
you so much.
engineering, leadership, and building system that really serve people. It's really amazing to have you on the show. And for my audience who wants to kind of reach out, check the show note for more about Jessica works and projects. The link there's going to be a link there to actually make you reach out to her. This has been the Making of Me podcast, and it's really a pleasure having you on the show, Jessica.
Thank you, Aero, for this opportunity. I really appreciate it.